I'm Peter Wormald. I'm the Principal Heat and Byproduct Manager. I work in the Heat and Byproduct and Delivery team for the Coal Authority. The talk today will be discussing mine water energy, which is available across the UK at surface from the Coal Authority treatment sites. And the Coal Authority is keen to support the regeneration and the provision and utilisation of this sustainable resource into former coal mining areas. So on the screen you have the Bates mine water treatment scheme, and you can see the iron being precipitated out in the lagoons before the mine water flows through the reed beds and out into the environment. But this mine water also contains over 4 megawatts of heat, and the local Blythe community, together with the Port Authority, are keen to harness the energy. And interestingly enough, just in the distance, you may be able to see the Renewables Energy Centre at the port, which is linked to the offshore wind generation out into the North Sea. So I'll firstly mention very briefly the difference between the two sorts of heat schemes that the Coal Authority is supporting through mine water. And then I'll pass on to look at the heat potential associated with our mine water treatment schemes across the UK, touch briefly on 2 case studies, and then finish on some key considerations to consider when accessing mine water heat at surface. We heard my colleague Keith Parker and others like Charlotte talking about standalone borehole schemes over the last couple of days. So just to reiterate that the standalone borehole schemes are based on careful targeting and drilling of boreholes to lower seams and abstraction of water, and once heat is removed, re-injection to upper seams. In contrast, bolt-on heat schemes, as we call them with the Coal Authority, or schemes that are related to our mine water treatment sites, are schemes which have the mine water already at surface and are being routinely treated. And the heat is delivered to development via a bolt-on to the shaft pump pipework. And that's shown in the top graphic there, with pumping from the shaft to surface for treatment in the mine, for treatment in the treatment scheme, and connection of the heat to the exchanger and development. So the capital costs are generally lower for bolt-on schemes, but heat access is fixed to the location of the treatment site, whereas standalone schemes have higher capital costs associated with borehole installations, but are typically more flexible in location across the coalfields. Turning to the distribution of our mine water treatment schemes across the UK, they're shown here on the right, across the coalfields in grey. So we have 78 treatment schemes in the UK, which treat 217 billion litres of water a year in active or passive schemes. 4,000 tonnes of iron per year are removed from the mine water, plus other metals. And the water flow rates range from less than 10 to 380 litres a second. And we have, through our records and our extensive operational experience, we have long-term pumping data to provide confidence on temperature, water availability, and the heat potential associated with mine water at the surface. There's a snapshot of the mine waters that we treat at the bottom slide, but mine water is typically low to medium salinity and near neutral pH. Turning now to the heat potential of these schemes across the UK. Previously, there's been some work, obviously David Wall's research in Scotland and others, and some work in Wales, I think with the BGS, Gareth Farr and others. And this is an attempt to pull that together with the heat potential across England as well. So this is, I believe, the first time the heat potential of mine water emissions at surface is being shown. So the map is graduated, or color coded according to heat potential. The red circles are those schemes which have over 3 megawatts of heat potential, and they're also separated between gravity treatment and pump source treatment. So the total heat potential of the schemes, looking at those that have a potential of over 0.5 megawatt across Scotland, Northeast England, the Midlands and South Wales, is approximately 76 megawatts available of heat across the UK at surface for linking to development. Of course, not all of these sites will be suitable, but that's a broad estimate. If you turn now to those which are marked as red or orange on this map, those are the substantial opportunities, and those that have over 1 megawatt of heat available. And I guess as a background, 0.5 megawatt will cover, as a rule of thumb, 0.5 megawatt will cover the heat load of approximately 500 homes, depending on the house type and SAP rating. So if we turn to the substantial opportunities, then they account for 61 megawatts of heat at surface. So at least 1,000 dwellings could be linked to schemes of that order of magnitude. So the Coal Authority is currently supporting 6 heat schemes across the UK. As you see from these numbers here at the top, the 2 areas of biggest potential are the Central Scottish Belt, something over 20 megawatts of heat available, and Northeast England, approaching 30 megawatts of heat available. The additional areas in the Midlands and South Wales. So the schemes that we're currently supporting are those shown in red. In Scotland, we've got Polkemmet and Blindwells, and I'll be talking about Blindwells a little bit later on. In the northeast of England, we're supporting Bates, or project linked to the Bates scheme, as I mentioned right at the beginning, and the Symposium Garden Village project linked to Dordon, which I'll talk about a bit later. But I think it's worth calling out that there's still significant, huge potential across both of those regions and elsewhere in the UK. In Scotland, in Central Belt, Fife has, in the Fife region, the Francis Mine Water Treatment Scheme and Pit for Rain schemes have huge potential. In Northeast England, Lanesley, over 6 megawatts potential, Chester South Moor, approaching 5 megawatts potential. Across the Midlands, Woodside and Woolley both have over 2 megawatts potential. And in South Wales, Moor Lice is over 3 megawatts and Taff Merthyr 2 megawatts. Moving on to briefly look at 2 case studies. The first, the Symposium Garden Village project that's been underway for some time. Mine water energy will be sourced from flows to the treatment centre, which is the active chemically dosed treatment centre. That's shown at the top and bottom right. The mine water is being treated. So the Symposium Garden Village development will link to the mine water treatment scheme that has a heat potential of approximately 1.6 megawatts. Current heat pump modelling shows a COP of approximately 4, And the project is led by Durham County Council. The scheme was originally based on 1,500 homes with a lifetime saving over the 25-year period of approximately 64,000 tonnes of CO2. Currently, at least 750 homes will be linked to mine water heat. Returning to Scotland and to the Blindwells development near to Edinburgh, the top slide shows our Blindwells mine water treatment scheme, a passive reed bed based scheme, and the location of the mine water abstraction points and pumping into that. Turning to the bottom slide, Borough Happold, with the support of Zero Waste Scotland, have recently produced a feasibility study for the Blindwells development for the developer Hargreaves Land. The development itself comprises, or the first phase of the development, comprises 1,600 new homes at a town centre, including school, retail spaces and supermarket. Our mine water treatment scheme is located here adjacent to the development. And the feasibility study has shown a heat potential of circa 5 megawatts, and that can meet the whole of the phase 1 development I've just mentioned, which has a peak demand of 3.7 megawatts. The heat pump COP modelling has given an estimate of between 3.3 and 3.5 for the project. And heat network carbon savings over a 40-year period of around 1,120 tonnes of CO2 when compared to the counterfactual of air source heat pumps. Finally, then, to look at some key considerations, which stakeholders and all parties should bear in mind when looking to connect to bolt-on heat schemes or heat at our mine water treatment schemes at surface. So really would recommend early engagement with all stakeholders. So looking at the key aspects concerning the treatment sites themselves, we have a commitment to treat mine water, and our first priority is to people and environment. We're keen to support and facilitate access to mine water heat via connection to the pump pipe work. There's also a need for protection of the reed beds on passive schemes, if present, to ensure that the temperature drop effect with extraction of the heat doesn't impact the metal recovery ability of the reed beds. Moving on to operation and maintenance aspects, from time to time there will be need for changes to pumping rates and of course scheduled maintenance. But we will work with the service providers and the energy centre to minimise the impact of these on the heat provision. And we'll enter into long-term site-specific commitments to pump water, and depending on the site, anywhere between 25 to 40 years commitment to continue pumping, even if treatment were to be no longer needed for the mine water. Just touching on natural phenomena, we obviously can't assume responsibility for natural changes to mine water flow or temperature due to, for example, climate change or subsurface hydrogeological variation. On charging, the charging for access to mine water is set as the minimum level to cover our cost recovery, and the charge is based on the volume of mine water accessed, and that is currently £2 per 100 cubic metres of mine water accessed. We'll have a price escalation mechanism according to CPI, and costs to facilitate the mine water heat access will be reviewed periodically. There may be insignificant way leave or property charges as well. Turning to the contractual aspects, initially we'll look to establish the broad brush of an agreement through a head of terms agreement of how mine energy will be supplied. And that will be followed up with a detailed water access agreement specifying in detail the provision of mine water heat to the energy centre and development. That will contain a water guarantee which links provision of mine water to income. And as I've mentioned, the income that we expect to receive is minimum based on a cost recovery, but it's all about trying to facilitate access to this energy resource. And because of that minimum income, our liability will be limited to the income from the heat scheme that we receive. So there may be a need for insurance to be provided by the operator or others to cover that liability gap and any possible future impact of the scheme on the energy centre or coal authority assets, infrastructure and assets. Finally, the operator or developer should ensure that all the necessary regulatory and statutory licenses are in place with the relevant body. Thanks very much, and I can take any questions.